you help me. Okay, I try to set out the equations. We discussing together. And you help me with the Wolfram alpha part. Now we try to solve it by hand, or I don't know. You help me. You help me. See you consider it by hand is good or no, or check it out with the Wolfram alpha. Okay, ready. Okay, good. Okay. So in this moment you see the whiteboard, right? Everyone is ready to pay attention? Or no? Come on. Who is present? Hey, Annette, Alejandro, Leonardo, Robin, Gerardo, and the rest is coming on time. Okay. Okay, number 10 problem say, John wants to build 500 feet square deck behind his house. Yeah, I am recording. Thank you. Thank you, Phoebe. What dimension of the deck will minimize the length of the material? Okay, basically this is the floor plan of the young house. So basically they want to control one specific thing here. It's a Porsche something, I don't know. And the area is 500 square feet. And the dimension is the thing I try to investigate. No? In the sketch, they call this segment Y, XY. It's a classical rectangle in which one side is missing, no? This part is missing. This part, okay. No. Okay, so the equation is the objective function, okay, want to minimize, in this case, is the perimeter. Okay, the perimeter is equal to y or x plus 2y, no? Is the distance. Okay, entonces en Lagrange Multiplier language, this is the function f of x comma y that you want to optimize. Remember, we have in any problem of the optimization, we have two functions. The objective function, que is the function that you want to maximize or minimize, in this case minimum, and the constraints. And the constraint in this case is area. So bounded by the is subject to the area. Area is x times y equal 500. Expressed in the language of Lagrange multiplier is x minus y times y minus 500 equal to 0. And this is the g x comma y equal to 0. Okay, this is classical in the Lagrange multiply language. Okay. And remember, in the Lagrange multiplier, you compute the gradient of the function f. You compute separately the gradient for the function g, and you put together. Okay, but let's do it. The gradient is the derivative, the partial derivative. Okay, partial derivative is with respect the x is 1, 1, 2, no? Okay, this is partial derivative of the function x with respect to x, and this is partial derivative with respect to y. Okay, and also same idea in the g. This is my function g, and partial derivative with respect to x is y, because you consider que y is a constant. And when you differentiate x with respect to x1, no? Now y stay because it's a multiplier, no? And 500, no, because it's another constant, pero es addition, subtraction, the derivative is 0. Likewise, partial derivative with respect to y is x. Okay, this is the gradient. Easy, 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 easy. Now my equation are, remember, f of x, que este component is equal lambda g of x. F of y is equal lambda g of y. And the rest is the constraint, no? G of x comma y equals 0. This is the classical 3 equation. In our specific problem, this is 1. This guy is 1. Look at that. Equal lambda, que es a number. Lambda is a number. Multiplication by y. ¿Qué es this? Component. ¿Qué es this? Well, entonces 2 is this. Okay, our example is 2. Lambda x. Equation 1, equation 2. And equation 3, well, equation 3 is xy minus 500, or whatever you want to call it, the same, no? It's equivalent. This is our system of equation. Again, we need to solve solve the problem, no? Well, I suppose, also, in this case, it's easy by hand, no? Remember, one is excellent strategy for solving this is do something in order to eliminate lambda, because lambda I don't care. And my goal is no lambda, my goal is x and y. Therefore, you divide equation 1 and equation 2. 1 over 2 is equal lambda y over lambda x. And lambda is cancelled because I don't care. 1/2 is equal y over x. Cross multiplication, es obvio que x is equal to y. Bueno, okay. Entonces using the third equation. The third equation is, for example, use substitution 2y. Replace, there are many ways to do that. However, for example, you replace x for 2y. Entonces 2y times y equal 500. Entonces 2y squared equal 500. Y squared is 250. And square root both sides is is 5 radical 10. Because 250 is 25 times 10. And square root 25 is 5, no? Okay, so you find the value of the y. In order to find the value of the x, it's easy because the relationship between x and y is twice. Look at that in this equation. You multiply by 2, entonces 10 radical 10. Let me check in just in case. The thing work or doesn't work. If you multiply x and y, okay, suppose que es the area. Fi times 10 is 50. And square root 10 times square root 10 is 10. And 50 times 10 is 500, exactly the same as this. It doesn't work. However, if you want to find the total material, so the total length, you go back to the equation for the f, because the thing I want to minimize, no? So the thing I want to minimize, because this function is x plus 2y equal perimeter equal, I call f and x comma y, is 5 radical 10 plus, no, sorry, this is 10 radical 10. The x is 10 radical 10, so 10 x is the bigger, it's twice. Plus 2 times, que es 10 radical 10. Que es 20 radical 10. This is approximately to have some idea. 63.25 linear feet of material. I don't know si es aluminum, I don't know si es. Okay, okay. Do you understand the idea or no? It's easy, eh? This is super easy. This is super easy. You can use it if you want. Cal 1 for solving that problem. Of course, we can use Cal 1 for solving that problem because it's 2 dimension. Si it's 3 dimension or more dimension, because in the formula you want to maximize or minimize, participate a lot of variable, you want to find the collection of the variable que minimize or maximize the specific quantity. Well, entonces impossible doing by Cal 1 because the limitation of the Cal 1 is single variable. Suppose how we solving this problem in Cal 1? Well, let's do it in Cal 1. In Cal 1 we have again the same function, objective function and constraints. I suppose you remember one topic, no chapter, it's a topic of the Cal 1 in which your optimization thing. So the first equation, objective function, is the perimeter, and the constraint is a area. Entonces, suppose que you, for example, you isolate the y in the constraint, is 500 divided by x, and substitution in the objective function, entonces is x plus 1, okay, 2 times 500 is 1000 over x equal b. Entonces we have one function que contain only one variable, que es x. This is Cal 1 problem. So you find, for example, dp dx, because I want optimization equal to 0, no? Derivative x with respect to x1. Entonces you consider in your mind que this is 1000 times x to the minus 1, no? Entonces minus 1000 x to the minus 2, no? Apply the power rule, no? You move this negative 1 to the front and subtracting 1 equal to 0. So let me try to manipulate this. Well, this is equivalent to say 1 minus 1000 over x squared using positive exponent, no negative exponent. Therefore, 1 equal 1000 x squared. Therefore, x squared equal 1000. So you find square root both sides. Square root both sides. We have x equal. This is, well, you know, 1000 is 10 times 10 times 10. Square root this couple is like a 110 outside and stay inside 110. And we get exactly the same answer we obtain using Lagrange Multiplier. No? The rest is pretty easy. No? You find the y is half of this. If I radical 10, the rest is easy. Okay, to say no. Well, no. Okay. In the test, of course, you're using Lagrange Multiplier because it's a powerful tool to solve anything, 2 dimension, 3 dimension, n dimensions. Okay. Well, guys, you said let me try to. Okay, I copy one piece of paper, the formulas. 1 equal lambda y, 2 equal lambda x times y equal 500. Okay, let's check in this word, this computation in Wolfram Alpha. Could you help me or no? Now let me see. Sure. Okay, Wolfram Alpha. This is, today we play the game with the Wolfram Alpha. You help me, because you need to practice a little bit. Okay, my first equation is 1 equal lambda. Lambda equal L L capital L time, don't forget the time what? Time y. Space and I use it by equation by equation by and. Because you need to satisfy the first equation and the second equation and the third equation. 2 equal lambda L time x. Boom. Space and easy. X times y, big important, x times y separated by multiplication sign equal 500. Because you put x, y together, Wolfram and Alpha don't understand your problem and believe that x and y represent a new variable. You press enter. Okay, we have two solutions because Wolfram Alpha don't understand very well. Our problem is a geometry problem. In the geometry problem, we have no negative solution because the distance is positive. Entonces, x is equal to 10 radical 10, y es 5 radical 10. Lambda, que I don't care, the lambda value, is 1 over 5 radical 10. Okay. How you verification? Okay, actually, this value is a minimum. Or maybe it's a maximum, no? Because Lagrange don't differentiate si es mínimo or si es máximo. The only possibility is plugging in into the original function and determine, no? And you, for example, select another couple of value of the x and y, not necessarily optimized, and you compute the material, and you see that the material is bigger. It's another possibility. However, si I using Calc 1, let me see again. Do you see the whiteboard or no? Okay, let me see whiteboard. Okay, another possibility, take advantage, okay, we are doing by Calc 1. Maybe you're using the second derivative test in Calc 1, no? Okay, how? Well, you take this, this expression can represent the first derivative, and you compute the second derivative, the perimeter with respect to the x. Okay, derivative 1 is 0. This is negative 1000 is a multiplier. You apply the power rule. You say this is minus 2 fly in the front. You say it's 2000, no? 2000 positive because negative positive. X to the minus 3, no? Que es equivalent to say 2000 over x cubed. And when you plug it in, our value is x here. You can see, not as I doing is greater than 0. See, the second derivative is greater than 0. It's because the concavity of this function is concave up. Entonces the extremely point es el mínimo. En Lagrange, bueno, entonces you select another x and y different to the optimized, increasing or decreasing, and plugging it into the original function and compares the material you need. Any question, guys? Any question? What part confusing? What part you don't understand? What part you suppose you fail on the test? No? No fail. Come on, opinion. I want to Shagir, David, Omar, Jocelyn, Annette, wow, Alejandro, Leonardo, Robin, Gerardo, Fiddy, Marco, and Ricardo. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 students. So we have 50% of the enrollment because in this class we have 24 students. I suppose that 50% only pass. Okay? The rest I predict, you know. Okay. No problem. Clear like a water or confusing? Crystal clear. Okay. Let's do a number. What number now? 11, no? 11. 11 is find the rectangle of maximal perimeter. Wow. That can be inscribed in the ellipse set with the equation. So one ellipse is given. X squared plus 4y squared equals 4. Okay. I express immediately the ellipse in standard form divided by 4. Everything because I know that the standard form of the ellipse right hand side should be 1. So x squared over 2 squared or 4, whatever. 4. I know 4 plus y squared over 1 equal 1. So I determine that the a value of the ellipse is 2 and the b value of the ellipse is 1. No? This is a squared and b squared is invisible. The reason is because it's 1, therefore b is 1. So we are in front one horizontal ellipse because the major axis lie on the x-axis. So we have 2 here. 1, 2, 1, 2, 1, 1. Our ellipse look like that. 1, 2, minus 2, 1, minus 1. Okay, however, they want to investigate one rectangle inscribed. What is that? I suppose que es something like that. Rectangle. See a rectangle, you know, the length is parallel, I suppose, to the x-axis, and the width is parallel to the y-axis. Okay, this is the famous rectangle que es inscribed in the ellipse, and I need to maximize this perimeter. So the blue part maximum, the blue length, the blue material maximum. Entonces, we have again two functions. Objective function. Okay. I suppose que this point in general is x, y, no? This point is exactly the same, pero es minus x, y. This point is a point minus x, minus y, and this point is x, minus y. Okay, si ese rectangle satisfies this condition. No say I need to find x and y. I have no idea who is x and y. Entonces, the objective function is always the function that you want to minimize or maximize. Entonces, the thing que I want to maximize is the perimeter. Perimeter max. Well, perimeter, you know, is 2 length plus 2 width, no? Always in geometry, no? But in this case, specific example, this is the length, and the length is x twice, so 4x. Makes sense? Because my formula has two lengths, but this length is formed by x plus x, 2x, plus 4y. This is my formula for the perimeter for the rectangle inscribed in the ellipse. Entonces, this is the I need to maximize. Maximize. Ahí está. I don't know if spelling is good or not. Maximize. Entonces, we have constraints. The constraint function. The constraint, sí, function. Que normally we call. Okay, this is our and the Lagrange language f of x, y. SG x, y equal to 0. Well, in this case, I take this. It's a non-necessary standard. You take the original. The original is, x squared plus 4y squared, que es el elixir, minus 4 equal to 0. Okay, this is G. Constraint. Because somehow the elixir bonded the rectangle. Okay, this is the most important for me. Set up the equation properly. And understand the problem. It's always the challenge. Set out the equation. Okay, good. Now compute the gradients. So I know the fantastic tool that we have in our hand, Lagrange Multiplier, in which you compute gradient of the function, gradient of the constraint, and you know that this gradient is a vector are parallel. And parallel means que is equal by one multiplier, Lagrange multiplier, que es lambda. Okay, the gradient for this guy is 4. Okay, because when you differentiate this with respect to x, f4, and with respect y, f4, this is my gradient. This is my gradient. And the gradient of this, that's different. Differentiate with respect to x is 2x. And differentiate with respect to y is a. Everyone follow me? Entonces, our equation, in this case, we have 3 equations, no? Is 4 equal lambda 2x. This is my first equation. My second equation is 4 again. It's a coincidence. Lambda ay. Equation 2. And finally, x squared plus 4y squared equal 4. Equation 2. Entonces we focus in this. Entonces I want to do, what do you think, guys? By hand, let's do it by hand, or let's do it using Wolfram Alpha? And you can help me or no? And remember, we need to obtain the location, the position, no? The location of the rectangle. Entonces, basically, the rectangle is formed by 4 points, no? So I need to find, well, but it's easy because you have x and y. You have the location for this point, and this point, and this point. And by curiosity, if you want to find the total perimeter, you apply the formula of the perimeter, and that's it. So what do you recommend me? Doing by Wolfram Alpha or? Yeah, I suppose yes, right? And the real, come on. Doing that. I'm waiting for you the answer. I have my piece of paper, I suppose. I suppose you know. Everyone working, come on. I suppose everyone open Wolfram Alpha. And you put equations. Separated by and. Lambda is no lambda. Lambda is capital L. Or whatever letter I call capital L. So you could call another name, it's okay. 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 Erase everything. New problem. Except the word solve. I typing 4 equal 2 lambda or 2x lambda, whatever. 2 x. When you have number and variable, not necessary time. Now time is mandatory now. Time lambda. And 4 equal ay time lambda. And well, x squared plus x squared plus 4y squared equal 4, no? Equal 4. Okay, this is my equation. Let me see what's going on. Boom. Wow, what the hell is that? Okay, I copy is y and x. Oh, yeah, you're right. Okay, do you get the same answer like me or no? Do you get the same answer like me? Yes. Everyone, guy. Okay, this is a review, no? And the review is for practice. Okay, for practice. Entonces es important que everyone try to do by yourself at least one first time in your life, no? Because it's different when you are doing by yourself and when you're watching some people doing by himself. Okay? Okay. So the answer that I can see is y is equal plus or minus 1 over radical 5. You want to rationalize, you can. And x is equal plus or minus 4 radical 5. And this is, you can format the 4 point. For example, in the first quadrant, well, okay, in the first quadrant, I take the two positive solutions. At this point is 1 over radical 5 positive, comma 4. Sorry. This is 4 because this is x. And this is y. Y is 1 over radical 5. And so on. In the second quadrant, when you take the negative solution in the x and the positive solution in the y, and the third quadrant both negative, and so on. Okay, now finally, in order to find the perimeter, okay, we're using that formula. And that formula is perimeter maximum, I suppose que es máximo, is, we don't see the web, oh, sorry. Okay, sorry, I forgot to share. Okay, the thing I explained, do you see now? Okay, this is the solution. Okay, good. This is the solution I get in Wolfram graph. So what is the interpretation? The interpretation is, well, we have 4 points. For example, in the first quadrant, you take the two positive solutions. Okay, this point is the point 4 radical 5, 1 radical 5. In the second quadrant, well, you change the sign of the negative, the x value. In the third quadrant, both are negative, and the fourth quadrant, y is negative, except positive. And we have 4 combinations, no, to find the corner of this famous rectangle. Bueno, entonces en order to find the, suppose que the maximum perimeter, que es the thing I want to maximize, is, well, you using that formula, is 4 times x, que is 4 radical 5. You take the positive solution because because it's the distance, no? Plus 4 times 1 over radical 5. This is 16 over radical 5. This is 4. This is 20. 20 over radical 5. Entonces, well, okay, leave it like that, or rationalization, either way, radical 5, radical 5. Entonces radical 5, 5, entonces 4 radical 5. This is the maximum perimeter of the famous rectangle inscribed in the ellipse. Any question? Any question? You get the idea a little bit later or no? Lagrange multiplier. Good. Okay. Let's move on to 12. Problem. In the 12th problem, we have find the extremity. Okay, in this case, no geometry, no. It's just a function. Okay, this is 12, no? 12. We are doing 12 now. 12. We have function 3x plus 4y, and subject to means constraint. Entonces the subject to x squared plus y squared equal 100. Okay, if you think about 3D problem, we have one surface and we have another surface. What surface it is? Name. What surface is this? Name. I need to know the name. Name of this surface. Surface. It's a plane. The first one is a plane. Very well. Plane. And the second? It's no plane because it's a square, no? It's what? Nobody know? X squared plus y squared equal 100. One clue is que one variable is missing. No, ellipsoide, Gerardo. It's cylinder. Circular cylinder. But when you are doing this graph, look like that. An ellipsoid is, something like that. Ellipsoid. How do you know? Because x squared plus y squared plus c squared equals something is ellipsoid. But c is missing. When the one variable is missing, it's because a cylinder, the surface that we are talking about is a cylinder. Okay, entonces cylinder extending along the z-axis, que es the variable que es missing. And when the variable is missing, you consider it as all real number. Make sense? I need to repeat one more time this idea. I repeat 1,000 times, I suppose. Make sense. Make sense, Gerardo. Okay, entonces now, let's compare, as always, Lagrange multiplier format. It's ready, no? Almost ready. Gradient of this guy. Well, it's 3 and 4. Remember, partial derivatives will respect the... it's a constant because it's a plane, and the plane is flat surface, and the rate of change is a constant, no? However, let me write here in the format Lagrange, que es g, y is equal x squared plus y squared minus 100 equals 0. And you compute the gradient of g. The gradient of g is 2x, 2y. Partial derivative is with respect the x, 2x. Partial derivative with respect the y, 2y. And the set of the equation is 3 equal lambda times 2x, 4 is equal lambda times 2y. And the constraint is x squared plus y squared equal 100. Okay. Always the problem is similar. We have three equations. Well, and you have three equations because we have only one constraint. More complicated equation, more complicated problem can contain several constraints. But no, we don't touch this. And so we have more. But it doesn't matter because you put it in the computer and you solve it. Entonces, somebody can help me or no? To determine x, y, and the minimum. Come on, sure. Come on. I am boring to do that. I waited for you, pero for today, quickly. This is easy. You open Wolfram Alpha. You type in the equation, separate by and. So the format in Wolfram Alpha is solve. And you copy, for example, the first equation is 3 equal L. Well, okay, much better like that, I suppose. 2L times X. Space and space 4 equal 2 again. L times Y. Space and x squared, this is the power symbol, plus y squared equal 100. Okay, it's a plus or minus 6. Now let me see, plus or minus 6. Yeah. So Gerardo say that the solution is x equal plus or minus, okay, plus or minus 6. And y is plus or minus 8, no? It's 8. Okay, correct. Okay, now what should I do? Well, I need to find maximum minimum, no? Because there are no specification, or it's extremely value only. The use substitution where? In the original function, no? In the original function, yeah, in the original function. Okay, you evaluate, for example, at 6,8 positive. You consider the positive solution. I get one number. And you evaluate in the negative solution, negative 6, negative 8, no? Okay. Yeah, I suppose this is 50. This is 50 because it's 18 plus 32, no? 18 plus 32 is 50, right? 50. And likewise, it's negative both and negative 50. Okay, so this is the mean, the max, sorry, and this is the mean. End the story, I finish. We are the best, no problema. We are ready to destroy any problem of the Lagrange multiplier. Any question? No? Okay. Let's move on to 13. I suppose that we have time today to introduce a new chapter. Only introduction. Motivation. Because anything que voy a estudiar. Entonces, 13 say, well, find the point on the circle x squared plus y squared equals 4. It's closer to the point 3,4. Wow, what the hell is that? Okay, we have equation for the circle. Okay, is x squared plus y squared equals 4. Okay, let me try to do the sketch to understand. Remember, guys, the geometric interpretation is extremely important. This is a circle in 2D. It's a circle. The question is, Professor, how do you know I analyze in 2D or 3D? This is important question. This is good point. My recommendation is doing in both 2D and 3D. When you see next chapter, The next chapter is complicated. So you see, well, let's analyze in 2D, let's analyze in 3D, and you get the big picture about the problem. So basically, it's a circle with the center is located at the origin, 0,0, and the radius is 2. 2 negative 2, 2 negative 2. And the famous point is the point 3,4. It's a point, isolated point, 3,4, 3, 3, 3 here. And 4, I suppose, is twice, double, 4. 3,4. Entonces, I need to find closest minimum distance. Using intuition and common sense, I suppose. Okay, look like that. I don't know exactly what is this point. This is the goal, determine that point. But at this point, I want to call in general x, y, no? Okay, entonces minimize distance and between one circle and one point. This is the challenge. Entonces, objective function es the function que I want to minimize or maximize, que es the distance. So the distance is square root. The distance is subtracting. You're subtracting the x component. 3 minus x or x minus 3. It doesn't matter the order because it's a square. And y minus 4. This is the distance formula. This is the equation que represent the distance, the famous distance I want to minimize. Minimize. Okay, minimize. But remember, when you to avoid the square root and the derivative, because when you want, okay, I need to find the derivative or gradient or partial derivative. Entonces I ignore the square root y I consider this is common sense. This is no que the objective function is only this function. The reason is clear. So you consider this and you will be able to minimize this function. It's obvious that you minimize the distance because there are relationships between this. The only relationship is the square root. To avoid the square root, definitely you delete mentally the square root. This is my objective function I need to minimize. And the constraint, well, the constraint is obvious that the constraint is a circle. The constraint is a circle because any point I want to investigate is on the circle. This is the constraint. Subject to this constraint. Entonces, the constraint in the Lagrange multiplier language is g x, y is equal x squared plus y squared minus 4 equals 0. Ready. You are ready to start. After the definition, objective function, and constraint. I compute the gradient. Gradient f and gradient g. Well, gradient f is well. Differentiate this with respect x. Well, I suppose que es 2x minus 3. Yes or no? Because you apply the chain rule, this exponent go to the front. Okay. This exponent go to the front, and you're subtracting 1, this is 1, and the derivative of the expression inside is 1. If you want, you write like, sorry, 2x minus 6, correct? Correct? After the multiplication, these two. Why not? Likewise, the partial derivative with respect to y is 2y minus 8. Done. I compute the gradient for the objective the radian of the constraint is easy, is 2x comma 2y. Similar as the other problem that I did before. The set of the equation is 2x minus 6 equal lambda multiplication by 2x. 2y minus a is equal lambda, we are lambda multiplication by 2y. Equation 3 is always the constraint. I don't know why I like to put in the other way, no, in the implicit. No, we put like that. Because for me, I suppose it's easier in algebra. Well, no, actually, I don't do by hand this. I do by Wolfram alpha. Wolfram alpha. Does you help me again with the Wolfram alpha or no? Somebody. Come on. Not only Geraldo. Another participation. Come on, guys. Sure. Come on. Carlos. Duque. Heidi. Bahor. Charin. Okay, guys. Open Wolfram alpha. Go to the algebra. In algebra, you type in the equation. Separate by and. Press enter and you get the solution. Do it by hand. This problem is just a little bit, not too much, more complicated. Okay, entonces, how you type in Wolfram alpha? Something like that. You put solve. Entre paréntesis, no space. You put 2x minus 6 is equal L or 2L x 2L times x. Important this time. Space and space. This is a typical format. 2y minus 8 equal 2L times space and x squared plus y squared equal 4. Suppose some student doing different order or whatever. You put 2 times L times x or 2 times x times L. It's the same, right? Entonces, the important thing is you have number. So Wolfram alpha suppose default, and the calculator, also the graphic calculator, or you know, another. Guy, are you familiar with the symbol lab? Or no? Symbol lab, creo que es the spelling. Okay, Ricardo dice yes. Okay, we can use a symbol lab, or symbol lab, or Wolfram alpha, either way. The answer is, wait a second. The answer is, we get the lambda or the L 3/2, and this corresponds with the x equal 6/5, and y corresponds with the 8/5. This is one possibility. Another possibility is when the lambda or L, whatever you want, is 7/2, x is equal minus 6/5, and y is equal negative 8/5. Okay, entonces in this case we can do plugging it into the original function gets distance. Or using your imagination or common sense, is super important in the real life. We have one point, que is the point 6/5, comma, A/5. And this point lie in the first quadrant. Exactly, we predict at the beginning. At the beginning, using my imagination and my common sense, the closet. I don't know exactly what is the position. Determine this. Entonces, this I suppose que es the minimum. But the second is in the third quadrant. Wow. It's exactly the image, but in the third quadrant. I suppose que es the maximum. Minus 6/5, comma, minus A/5. But I don't care this because the problem talking about closet. Find the point on the circle that is closer to the point 3,4. Okay, the point is 6/5, comma, A/5. And you want to compute the distance, just plug in this x and y value into the distance formula, and that's it. Pero no. Not necessary. You want, you can. Pero not necessary. Any question? Guys, we have in our hand fantastic tools to optimization function and multivariable. Okay? We are strong. In optimization. Okay, let's do one more extremely. How do you feel? Remember, in my test, well, you see the test. There are no extremely complicated problems, no? We discussed in complicated in the lecture. However, in the test is regular, you know? And the student can pay attention, understand, have no problem, I suppose, no? We have two more examples, 14 and 15. What do you think? Do you consider that we are doing, or we move to the next chapter, introduction to the next chapter? We have 30 minutes. We are doing 14 and 15 or no? Opinion. Oh, you are boring. Professor, okay, this is all about the test. I think it is a mistake. What the mistake, Gerardo? Mistake in the what? In the test 2 mistake. Say the ZDX. Probably. Let me reconsider this. But okay. The thing you talk now is completely to my question. My question was, do you consider it useful continue doing a Lagrange multiplier problem like 14 or 15, or we move into the introduction next chapter? Opinion, guys. You feel strong? Not necessary to do more? Opinion. Feel strong. Okay, good. Gerardo, what is your concern? Is it can do another? Okay. We do another. Okay, bueno, another. Let's do it one more. One more of the. Let's do it 14. No, 14. After Gerardo, when the class is over, you stay a few seconds, and you explain what is the mistake of the test. See, there are mistakes. I fix it. Okay. Because maybe when I typing, I make a mistake. No, I don't remember. Okay, let's do it 14. 14 is find the extremity of the function 14. xy. Wow, it's a function. Subject. And this is the constraints. 16 x to the 4th power minus 32 xy plus y to the 4th power equal to 256. Okay, Entonces I realize que my function, bueno, my objective function is this, and my constraints is 16x to the 4th power minus 32xy plus y to the 4th power minus 256 equals 0. We compare the gradient for f, and we compare the gradient for g. Well, okay, the gradient of f is y and x. It's correct, right? However, the gradient of g is more complicated. Is, well, I suppose que es 64 x to the 3rd power minus 32 y. And derivative with respect to x, that part is 0. This is the gx. Okay, now gy is derivative with respect to y, derivative this is 0, derivative this is minus 32x plus something, plus 4y cubic. Derivative this with respect to y, 4y cubic, and derivative this is 0. This is my gradient. Super. And my system of equation is then y is equal lambda 64x cubic minus 32y, equation 1, x is equal plus 4y cubic, equation 2, and the constraint I just copy 16 x to the 4th power minus 32 xy plus y to the 4th power equal 256. It's equation 3. And you see now, this is extremely complicated. Doing by hand, I might be able to do it by hand, but it's crazy. It's crazy. And you spend, okay, this deviate attention. We are focusing on the optimization, gradient, calculus 3. Now you face this on the thing I forgot after negative 32. Oh, yeah. Thank you. I forgot x here because this guy is this guy. Thank you. Okay, now you put in Wolfram alpha. I don't want to. If you want, you are doing by yourself. The maximum occur at the point 2,4 and negative 2, negative 4. And the function at this point is 8. The function es obvio que es even. It's even. It's odd function. No? Yeah. But when you change doubly symmetric, is the same value. And this is the max. You could put this in Wolfram alpha. Que the point radical 2, minus 2 radical 2, and the point minus radical 2, 2 radical 2. The function evaluated at this point is equal minus 4. And this is the minimum. Okay? Okay. Do you see the complicated problems que we can solving using the combination, this new concept que es Lagrange Multiplier, to optimization plus the potential of the software, que always is possible to solve in the real life, because you are engineer or mathematician or physics, scientist. Okay, entonces now in the next chapter we dedicate the rest of the time to explain one nice, it's like a refresh. Next chapter is complicated, very complicated, but today no, today is only introduction to motivation to study this, que es de múltiple integral. O sea, we study doble integral, we study triple integral. But I want to recall the Cal 1, as always. In Cal 1, we have only one. In Cal 1, we compare, for example, the integral from a to b, the function single variable dx. This is the classic, and you compute the antiderivative and evaluate the point, no? Entonces, you say, si I ask you, well, what is the interpretation for the integral? Entonces, everyone, the answer is, no, professor, this is the area under the curve. Okay? And you are right, but not totally right. Because suppose that you, for example, you square the integrand function and multiplication by pi. So now is no area, is the volume of the one solid when you rotate the function in the x-axis. Entonces now, or whatever, si, o sea, depending the integrand function is the area, is a volume, or maybe it's a r length, no? Suppose that we compute the integral for the a to b, and this is a square root 1 plus the first derivative square dx. This is the r length formula. Or another more complicated, the surface area. So depending the mathematical que you manipulate the integrand function. Okay, this is the integrand function. Integrand. I suppose que es the function. Depende the answer, depende the interpretation of this answer. Si es the area, si es the length, surface area, volume of the solid revolution, and so on. Entonces, actually, what is the professor? Entonces, what is the interpretation of the integral? Bueno, integral is operator. Give me the Riemann Sum. Riemann Sum is the interpret Riemann Sum. Let me recall, this is classical, pero en Calc 1, the professor explained, when I teach him, explain, but not too much, emphasize this idea, because I consider it not important. No, this is important, This is the interpretation, Riemann Sum, because this allows us to generalize for any dimension, que es multivariable calculus, or another branch of the calculus. Okay, what is the idea? The idea is, well, we have a function. This is a function. We have one specific interval here, AB, and we make a partition. And this is the famous delta x. Delta x is b minus a divided by m. I don't know si I do the partition using 4 value, 20 value, 200 value, but basically I take in each interval You take in each interval a rectangle. And the height of this rectangle is the f of x. Evaluating one specific point, and between this and this, I call x after. Yeah, I put after weird because it's completely arbitrary. Okay, some people study, bueno, si I take the left endpoint, or I study the right endpoint, or si I study the midpoint, it doesn't matter what you take. When you approach it to the limit, any Riemann sum converges to the same value. So what is the Riemann sum? The Riemann sum is the summation from I1 to M. What is a count variable is, suppose here 0, 1, 2, 3, 4, 5, 6, 7. I don't know si the partition is 20, maybe. Entonces N is 20. And the multiplication F and X after, so I, because I take, for example, this guy X to I, and this is X to I plus 1. I take in the middle one arbitrary, I call X to I after, much better. Multiplication by delta X. And delta X, bueno, I consider que se consta, pero no necesariamente se consta. Okay, some more strictly way, you suppose different delta X. This is crazy, no? Normally you assume the same delta X, pero no necessarily it's the same. Okay. Entonces delta Xi in general, this is a Riemann sum. However, when you approach it to the limit when the delta Xi approach it to 0, so in other words, you are using the partition smaller, or the number of the partition approaching to infinity. This Riemann sum is equal to the integral a to b f of x dx. Entonces now magically, this is magic. This is science fiction, in my opinion. Okay, is you apply calculus, you find the antiderivative. Okay, antiderivative using the rule of the antiderivative, and evaluate the antiderivative. I call capital X. Evaluate in between A and B. Entonces F and B minus F and A. Capital F is the antiderivative. So antiderivative is no limited. Remember, when you compute the antiderivative, you put the arbitrary constant. However, when it's defined integral, not necessarily arbitrary constant, because you evaluate directly in the endpoint. Okay, so in this problem, we have two dimensions because of X and Y context. So the context is 2D. However, the region is 1D. What is the region, professor? Well, the region is the interval. So you are doing the partition of the one region, que es 1D, and N, M, or M, no M, N element. Okay, entonces, however, we can generalize. Yes, we can generalize. For example, suppose now we will have in 3D context. Suppose that we have now 3D context. Okay, the famous 3-dimensional space we frequently using every day in Cal 3. Suppose that we have surface, the surface that you never memorize. This is Z equal F and X comma Y. This is 3-dimensional context. However, I make a partition, suppose in XY plane, on XZ plane, on YZ plane, but no, to make easy, I want to do the partition in the XY plane, not necessarily. After you see it in any plane, for example, here we have rectangular region. This is my region now, region And by the way, this region is 2D. So in 3D context, the region dimension is 2D, the rectangle flat. And you are doing partition. But how you are doing partition? Well, you are doing partition in X and Y, like that. So we have a very small rectangle, not necessarily square, rectangle. And the region, suppose que this limit is AB, and this limit is CD and Y. So my region is A comma B in X cross, so like a Cartesian product, no? CD. So that means it's all the set in between A and B, and C. This is the region representation, no? And we have delta X I, que is B minus A divided by M. Because in the x-axis you divide by M division. So you are doing partition n time. Similar to and delta yi is d minus c divided by m. Not necessarily the same. Si es the same, it's okay. But this I am doing partition and different. Now I am ready to set out the equation for the Riemann sum. Okay, but in this case, double Riemann sum. Entonces pay attention, and now you try to understand the interpretation for the double integral. Double, because in this case, double integral. Why double? Because we have to sum. The first sum is supposed for the whatever, I 1 to M. And you take the function, that function, and you evaluate that function and the specific. Suppose I focus in one rectangle here. Bam, 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 bam. And so I have one point here. Okay, this point is a function evaluate at xi after I. Okay, it's the high. Entonces es f xi after yi after. Multiplication by delta xi. However, we have another summation. Entonces, another summation because the region is two-dimensional, no? So, for example, you navigate in X. So you adding this rectangle plus this rectangle plus this rectangle. This is X direction. But you need to cover the entire region. To say you need to move, of course, slow in the Y direction. Entonces, suppose J1 to M, because the partition is different in Y. Of delta Yj. Actually, this point is double subscript I comma J. Because suppose we have a partition 4-4. Actually, we have 16 rectangle, no? The first one is 1-1. The second is 1-2, no? So you navigate for the X, and you increasing faster the first summation. And to say you take this point, evaluating the function, obtain this segment, a multiplication by the dimension for the dx and dy. And this is when you compute the limit, when the n approaches to infinity and So we are doing very think. Okay, you find the double integral. The double integral. Woof, double integral. Why double integral? Remember, okay, when you see limit sigma notation, it's the integral. We have limited, do limited, and 2 sigma is double integral. And the region R, who is the region R? This is the region R. Of the multiplication of the function, and then not necessarily subscript because it's totally continuous, xy. And you have dx dy, dx dy. Doesn't matter. This is beautiful. Double integral f of x comma y dy dx. So the order is no important. So how you travel in the region, you travel like that. Bam, 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 bam. After, bam, 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 bam. After, bam, 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 bam. This is, I suppose, that you integrate first. The order is dx first. But if you're doing this order, bam, bam, doesn't affect, you can do that. Okay? Entonces, the question que fly in the air. The question que fly in the air is, what is the interpretation of the double integral? When you compute double integral and the answer is 200, 40, 50, what is the meaning of this number? Interpretation. Interpretation. What do you suppose is the interpretation using the common sense? Okay, what are you looking for when you compute a region surface? What is that? No idea. Nobody there to say one idea. Volume. Very well. It's a volume. It's the volume of the solid over, of course, it's a volume. So double integral volume. Volume que es bounded. O sea, volume over the rectangular region. Que you see que no necesarily es rectangular. We see a more general region. Pero it's okay. So far it's rectangular. And it's bounded in the top by the surface. Okay? This is the idea for the interpretation the double integral. Okay. One more important thing. So you suppose, using my imagination, get the integrand function. Look, this is important. Pay attention, please. Suppose so we have that situation. Double integral in the rectangular region R. Entonces 1 dx dy. Okay. The interpretation dx dy is a small rectangle dx dy. And when you multiplication dx times dy, this is the area. Okay, you sometimes is frequently using this notation. Double integral in the region R of the function f of x comma y dA. Entonces no, you don't define si you integrate x first, y second, or y first, x second. By the way, we can integrate in either order and the answer doesn't change. And some problem is very useful. Select the proper order of the integration because sometimes, so you, for example, integrate with respect to x first because you lie. I lie x first. No, doesn't work because maybe this function have no antiderivative. There are many examples in calculus que one function, the antiderivative do not exist. If you put in Wolfram alpha, you put in the calculator, wow, it's a mess. No antiderivative. So you magically, if you change the order of the integration, no dx dy, sino dy dx, entonces, it's easy. And everyone flow perfectly to the answer. Okay, but okay, I avoid the idea for when the integrand function is 1. Es obvio que this is dA, ¿no? Because 1 is a multiplier que es invisible, ¿no? Entonces this is the area. Wow, but what is the reason? Professor, ¿es a volume o es a area? Well, actually it's a volume. But what happens when the one volume, suppose a volume, the box, the volume is x, y, or length. Let me change the letter, no length. Length, width, and height, no? This is the volume. However, suppose one box que the height is 1. Entonces, the volume is equal length times w times 1. No, 1 is invisible. Entonces, this volume is equal area. Okay. Entonces, the artificial que we can using is, when you want to compute area using double integral, you're supposed to get the integrand function as 1. Because actually, the thing we are doing is compute the volume, but also supposed to get the height as 1. And these principles apply also in triple integral. The triple integral, the meaning of the triple integral, I don't see it, I don't want to explain now. In triple integral, we focus on double integral and double. We have a lot of things in double integral after triple integral, I promise. And this is the entire chapter, 3, double integral and triple integral. The interpretation of the triple integral, I have no idea. It's another thing in the 4-dimensional. However, so you suppose that the integrand function is 1. So you reduce the dimension, and the answer for the triple integral is a volume. Same principle, double integral, compute, the answer is volume, for sure, 100%. However, if you assume that the integral function is 1, is area. Okay, is area. Okay, one more thing I want to discuss. No, I suppose que no. I suppose que no, because you have too much work. You have a lot of homework. You have tests online and tests on paper. Okay. Gerardo, you want to say something que you see mistake in the test? Let me see the test. Let me share the test. Let me